Hello everyone and welcome to this week's lecture. In this week's lecture I'll be talking about timber as a construction material. So the learning outcomes for today, we'll be talking about the classification of timber. I'll briefly touch on the history of timber construction, and then we'll move on to discussing uses of timber in construction. I'll focus also on structural timber, the sustainability of timber, and then finally we'll be talking about some defects that you should look out for when you're using timber as a construction material. Station 1 for today, what is timber? So I'll be talking about the main properties of timber and how we classify it. The first point to note here is that timber is a natural material, so it's not manufactured. You obtain it from trees, obviously, and so when you look at its structural composition, it's mostly a cellular composite material. What that means is that you have various interlocking cells forming a lattice. Now, the reason for this structure is because in trees, you need to transport water, of course, from the roots to the top of the tree. Hence, why you need that cellular composite structure. To classify timber, we look at the trees from which timber is extracted. And for trees, we have two different classifications. The first classification is the endogenous trees. And these trees, they have an inward growth. So an example of that would be your bamboo, shown in the bottom figure. And you can see these hollow structures around the ring that go into the page. So that is the inward growth that we're talking about. Exogenous trees, and that's the second type. And these have an outward growth that is represented as rings in a cross section. And we can see from the figure at the top, that's an example of an exogenous tree, a cross section of an exogenous tree. And the rings that I'm talking about, these are shown in the figure. So you start off from small rings at the center, and then they increase in size as you move outside towards the trunk, the outside trunk of the tree. When we look at exogenous trees, we can further classify these into two types: softwood, which are characterized as light in weight and color. An example of that would be your pine. We also have hardwood, which is strong and heavy. An example of that is oak. So these two figures, this one represents hardwood and that one represents softwood. What you can notice in both figures is the interlocking cellular system that we talked about earlier. So these different cells and how they interlock with one another to form a lattice. And that's something common not only for exogenous trees, but also in endogenous trees too. Now for endogenous trees, they're classified as being weaker than exogenous trees. And that's why you find that, for example, bamboos, they're not used as structural systems, but are used as temporary structural components. For example, scaffolding systems, and that's to make sure that the structure can actually withstand extra loading, and hence why we don't utilize endogenous trees for our permanent structures. So bamboo is utilized in countries outside of Australia, of course. It's not commonly adopted as a scaffolding system in Australia, but a lot of other countries, especially in East Asia, they do utilize bamboo for their temporary structural supporting systems. Station 2 for today is where I'll be talking about the history of timber structures. Well, timber structures have been, one of the first primitive structures to be constructed by mankind. If you look at ancient civilizations, Egypt and Rome, for instance, these guys, they adopted timber structures for the roofing systems. their buildings were mostly composed of stones, and they had their roofing system as timber. The foundation systems for for buildings that were constructed from timber, the timber was driven or laid on the ground, and then to build the roofing system, for example, you had timber tied together using primitive ropes. Station 3, the advantages of timber. As you can see in front of you, there's a list of advantages when we're talking about timber. Let me start off with the first advantage. So timber is considered as a very strong material relative to its weight. So when you look at its lightweight, and contrast it with other construction materials that we talked about in the course, timber is the strongest, of course, relative to its weight. The second advantage is related to the fact that you can easily vary the shape and size of timber, and that's why it's adopted in different forms in construction. So you see, doors, frames, structural buildings composed of timber. So that varying types of forms that timber can be utilized for. A reason for that is because you can shape it into your desired building and your desired components. Plus, your size can vary, and that's easy to do. Connections are easy. So when we talk about connections, it's mostly the roofing system and how it's connected together, but also connecting your wall elements to your roof. Waste is minimal, and the reason for that is because given that it's easy to handle, it's easy to size and shape your timber structures, usually you can minimize waste because of that. It's very durable, but it needs to be properly treated for it to be durable. So when I say durable, I mean resisting termite and the impact of weather. And it also has a very strong resale value compared to other construction materials. So a couple of the advantages of timber for you guys to consider when you want to adopt it in a particular construction. Station 4 is where I'll be talking about the main uses of timber. And a lot of these uses are, of course, related to the advantages that we've already discussed. So I'll be demonstrating the different forms in which timber can be adopted for your construction projects. So the first use, an obvious use, of course, that you see, which is very common in construction, is timber formwork, right? So the advantages that we talked about, remember how we said it's easy to vary the shape and size of your timber. And that's, of course, a reason why it's adopted for formwork. So for formwork, you need it to sort of come in different shapes and sizes. You have formwork for columns, you have formwork for walls. So the figure on your left-hand side, this is a column, a formwork for a column. Now, they come in different shapes and different sizes, the columns and the walls, depending on your structural design. So you need the formwork to conform to the design of your building, and hence why timber is used for formwork, because it's easy to shape and it's easy to vary its size. Another application of timber in construction is framing, and I'm pretty sure you guys have seen on construction sites these framing structures, particularly for residential buildings. Now, for up to 3 floors in Australia, you usually have to design your timber frames in accordance with the Australian standard AS1684. But as you can see from the images, the framing can be utilized for your walls and for the roofing as well. Now, the reason that it's used for small residential buildings is because it's easy, it's simple connections that you can form between the different systems, so your roofing system and the wall system. These sections can be easily produced Again, that's relating to the fact that it's easy to shape and size your timber components. And construction is easy whether you adopt it on site or in prefabricated plants. A third use, of course, is for trusses. You can see an example of a roof truss over here from the National Portrait Gallery in Canberra. So connections, you can see them over here. So timber connections, easy to form as well, easy to size. Fourth application, space frames. So that's an example of a space frame, a roofing space frame. Again, there's a heavy reliance on different connections between the various components forming that space frame. Arcs, so it's easy to get an arc-shaped design through the use of timber. Again, you rely on the design of connections to form such a system. Cladding on the outside, you can get that as timber, and a lot of interior designers and architects, they like to use timber as it gives an extravagant look to your building. Doors and windows, so you see examples of a lot of these in the industry. Timber flooring, of course, again, as I said, interior designers prefer it as it gives this um, extravagant view to the indoors of the building. Now, when it comes to structural timber, and that's an image over here from Barangaroo, that's one of the buildings that they constructed. You can see that the columns are constructed from timber. The flooring system was constructed from timber as well. So the previous applications, it was for structures that where the loading system wasn't that large. So when we're talking about a truss for a roof, you have to resist just certain loads that are induced by the weather. Or when you're talking about doors and windows, these are structures that need to withstand some sort of loads, but they're not that massive loads. When we're talking about structural timber, a building such as the one that you see in front of you, this is where it becomes critical to analyze the loads properly. Now, the fact that you can use timber for large columns and for flooring systems, so for structural flooring systems, that's an indication of its strength as a structural material. If you want to utilize timber as a structural material, you can, of course, have multi-stories. And when it comes to multiple stories and the use of structural timber, there's two classifications of mass engineered timber that are commonly utilized in the industry. Now, the first type is the cross-laminated timber, CLT for short, and the second type is the glue-laminated timber, glulam. So let's talk about CLT. CLT is essentially a form of high-tech plywood. So it's cross-laminated, of course, and the reason for that is because you need the extra strength. That's why you can use it for flooring and for wall sheeting. Glulam, on the other hand, is used for large columns, beams, and diagonal braces. So we see applications of these two materials in this image over here. So, your columns and your beams would be formed from glulam, whereas the flooring system over here would probably be CLT. Now, when we talk about structural timber, of course, there's another application of structural timber, and that is pre-stressed timber. So this is when you have these tendons that are attached to your timber structure, and they're tensioned in a way such that it allows you to withstand greater loads for larger spans. Okay, so you can form bigger spans, bigger than your usual spans, so long as you have these tendons attached that are tensioned to a particular strength specified by a structural engineer. And the uses of that is because it gives greater performance when it comes to resisting earthquake loads. So in regions where there's heavy earthquakes, or there's heavy horizontal loads from winds that needs to be resisted by the structure, it's best to adopt pre-stressed timber. And you can see examples of applications in New Zealand. And New Zealand is a country that's prone to earthquakes, of course, and that's why pre-stressed timber is a major structural material that's adopted for a lot of projects over there. Now, station 5 is where I'll discuss the sustainability of timber. So, in terms of sustainability, it's one of the most sustainable material to utilize. Now, you have to be a bit careful when you say timber is sustainable, because for certain tree types, their cycle, so their growth cycle, usually takes hundreds of years. So if you were to adopt, timber from such plantation, that wouldn't necessarily be classified as sustainable, given that the cycle is very large for you to regrow, the tree. So we prefer, trees with short growth cycles, trees that we can actually replace easily. In terms of carbon, trees absorb 3.66 tons of carbon dioxide for each ton of carbon that's stored. So within your tree structure, for each carbon that's stored in it, there's 3.66 tons of CO2 from the atmosphere that's absorbed. Approximately 50% of the dry wood is carbon removed from the atmosphere, and that's the carbon that's stored within the tree. If you look at its production or its manufacturing, the manufacturing process doesn't require a lot of energy, so that's another sustainable point that characterizes timber. In the previous slide, I talked about the renewability of timber and how the cycle, the length of the growth cycle of a plant, affects the sustainability of your timber material. So typically we're looking at a 30-year growth cycle, so 30 years in plantations. That's when that's the sort of trees that we would adopt to get our timber from. Usually you can get 60 to 80 years as well, but the more years the growth cycle is, the less sustainable your material becomes, because it takes longer to replace the trees. Timber is reusable, so the individual elements that you have in your building can be reused in other applications. When you deconstruct the building, it has to be designed in such a way that you can easily remove the connections and utilize individual elements in the building. And when we're talking about recyclability, it's highly recyclable, and a lot of waste timber is actually used as chip in the construction industry. Now, the final station for today is where we'll talk about issues that are associated with timber. Several defects are associated with timber. So there's defects due to fungi, there's defects due to insects, and that's why we have timber that's treated to resist, termite. Defects due to forces, so these can be natural forces from the weather, such as rain, or they can be loads, so external loads imposed on the structure. There's certain defects that happen, in compression and in tension. There's also defects that occur due to the conversion process. So when we say conversion process, what I mean by that is the process, the manufacturing process that timber goes through. So when you remove it from the plant and you process it for manufacturing or to produce a final product, there's certain defects that can take place during that manufacturing process, and these are defects that would be classified as defects occurring due to conversion. Another issue that you have to bear in mind is the fact that timber does not behave equally in all directions. What I mean by that is the strength of timber varies according to the direction of the loading. If you were to load your structure in the longitudinal direction parallel to the grain, just like you can see at the top over here, that shouldn't be a problem because the timber is strong and stiff, parallel to the grain. However, if we were to load the structure perpendicular to the grain, like you can see at the bottom over here, this is when you will have issues. Now, this is important to bear in mind because when we engineer our CLTs that are used for our structural flooring, for example, we need to make sure that the direction in which the forces are resisted by the CLT, it's the direction that is parallel to the grain, so that's the direction that produces the maximum resistance to the loads, hence ensuring a strong structure. Okay, so for today, we talked about timber as a construction material. We discussed the classification of timber into endogenous versus exogenous trees, and the uses of timber extracted from these two types of trees. We discussed the history, a brief history of timber. We talked about its applications in construction, and we also pointed out to defects that you have to bear in mind, and several strength issues that need to be accounted for when you're utilizing a timber for your structural flooring systems.